We're going to continue with probabilities, and what we're going to do is we're going to look at dependent and independent probabilities. Remember that all probabilities are in between 0 and 1, so nothing less than 0 and nothing greater than 1. These formulas right here we're not necessarily going to use, but they tell us a lot about how the probabilities are going to be based. Dependent probabilities, our first probability is just like we see it, but our second probability is based off of our first probability, and we'll see that with a deck of cards. Versus independent probabilities, it doesn't matter what our first probability is because it does not affect what our second probability is. And we'll see that example with the dice. So first, looking at the cards, we know that there are 52 cards. We know that there's 4 of each type of card, and there's 4 different suits: hearts, diamonds, clubs, and spades. So when we're talking about 2 kings, we know that there are 4 kings. So we go 4 out of 52 and 3 out of 51. Now, once again, this is a dependent probability because once we have a king in our hand, there are now only 3 kings to choose from. So that's why there's the 3 there. The 51 is because we have 1 king in our hand, so that means there's no longer 52 cards, there's 51 cards. So that gives us 12 over 26, 52. Once again, you're welcome to reduce it, but I'm just going to keep it with the original fraction. Here we have a king and then a jack, so we know that there are 4 out of 52. And jacks, because we have a king in our hand, there's still 4 jacks out of 51 because we have a king in our hand. So that right there gives us the probability of 16, 26, 52. 2 hearts, there are 13 hearts because hearts would be one of the suits. And if we have a heart in our hand, then there's only 12 hearts left, and that would be 51. And then 13 times 12 is 156, and that would be 2652. 1 queen. This is kind of a tricky one because we don't know if the first card is a queen or if the second card is a queen. So it could go queen and then not a queen. So that's one possibility. Or what could happen is the first card could be not a queen, and then what we have is we have a queen. Now, what a lot of people do is instead of writing it twice, they put a 2 in the front. And what they do is they think of 2 ways for it happening. So it could either be a queen or not a queen. And that's like the complement of a queen. That's what the C is. Sometimes you put a little line depending on what type of textbook you're using. And then the other one would be not a queen, the complement of a queen, and then a queen. So either putting the 2 and not putting the other one, or don't put the 2 and then put the 2 fractions, whatever you prefer. And that's going to give us 384 over 2652. So those are dependent probabilities. Now we're going to look at independent probabilities. With independent probabilities, we're looking at 2 dice and 2 ones. That means the first one's a 1 and the second one's a 1. With dice, if we get a 1 on one die, it doesn't affect the other die. So that's why the probability doesn't change. Versus the cards, if we get 1 card, that changes the probability. So 1 out of 36. 1, 3 means that we have a 3, and then the other one is not a 3. So that would be 5 out of 6. Now, there's 2 ways that we can do this. Either the first one is a 3, and the second one is not, or the first one is not a 3, the second one is. So once again, putting the 2 is a little bit easier than writing it twice, and then that would be 10 over 36. No 4s. That means the first one is not a 4. And the second one also is not a 4. And that would be 25 out of 36. At least 1 5. At least 1 5 means it's the probability of 1 5 plus the probability of 2 5s. So the probability of 1 5 would be 1 out of 6 times 5 out of 6, and we times it by 2 because there's 2 ways that it can happen. Then the probability of 2 5s would be 1 6 times 1 6. So that would be 10 over 36 plus 1 over 36, which of course would be 11 out of 36. Now we're going to move into 3 dice. Once again, these are independent events. If I roll a die, it doesn't affect the other dice. So since we're rolling 3 dice, we now have 3 probabilities. So 3 4s would be 1 6, because that would be a 4, 1 6, because that would be a 4, and 1 6, because that would also be a 4. So that would be 1 out of 216. 1 6 means one of them is a 6, and the other 2 are not a 6. Now, if we were to rearrange it with the dice, the 1 6 could be the first one, or it could be the second one, or it could be the third one. We're not sure which one it is, so we times it by 3. 25 times 3 is 75 over 216. 2 ones. That means the first one is a 1, the second one is also a 1, and the third one is not a 1. Once again, we have to figure out how many ways can this happen. Not the 1 could be the first or the second, or it could be the third. So once again, there's 3 ways it could happen. So that would be 15 out of 216. And at least 1. Now, at least 1 means it could be 1, or it could be 2, or it could be 3. Now, one thing that you'll notice is that the first 2 that I put on there has a 3 in the front, but this last one does not. So this one has 3 ways of happening. This one has 3 ways of happening. This one only has 1 way of happening. All of them have to be a 2. So we have 75 out of 216. We have 15 out of 216. And we have 1 out of 216. And that right there would give us 91 over 216.